This tutorial is a quick introduction to linear equations using slope-intercept form. That's going to be the measure of how high or low something is. It's going to be the rate of change times x plus wherever you start. And in other words, that's going to be whatever y is going to be your slope times whatever x is, plus what is y if x is 0? Well, that's not going to make a lot of sense if you don't have an example, so let's draw a picture. And remember, y, there's your y-axis, there's your x-axis. Y is going to be the most important information on your graph, how high or low it goes. Let's say, for example, you're talking about water, and a number of gallons of water in something. And let's say it starts at 70 gallons. And we're going to measure how far it goes down in terms of hours. Let's say it goes down 10 gallons every 2 hours. Well, your graph is going to show that it's going down. You're not worried about the hours, you're concerned about how many gallons are there in terms of hours. And it shows right there that it's going down at a constant rate. Let's look at another example. Let's say we're talking about money. Let's say you start with $20. And as weeks go by, you're saving, let's say, $10 for every week. So you're going up $10 per week. Nice straight line, constant rate. There's my slope, up 10 over 1. So let's look at what you might see on a test. You've got y equals mx plus b. Again, that's how far up and down. And is equals the rate of change, that slope, times x, plus where you start on the y-axis, if x is 0. Let's say you hire a driver for $5 plus 25 cents per mile, and you have to write an equation that models the total cost in terms of miles. So that total cost is equals $5 plus 25 cents times each mile. So your total cost is y. That's money in terms of miles. So total cost is $5 plus 25 cents times miles. Y equals 5 plus 25 cents. Now notice that's a positive 5. We need to switch these around to make it y equals mx plus b. So a positive 5 and a positive 25 cents, you rewrite it like that. Now, let's see if we can use that to graph it. Slope-intercept form is the best way to graph it. You start at the 5. If x is 0, if you first are starting your trip, you haven't gone anywhere, you still owe them $5, and it goes up 25 cents for each mile. Up 25 cents, up 25 cents. Constant rate of change. There's our slope, there's our line, right there. Let's try another one. Let's say you have a pool that has 8,000 gallons of water. That's when you start. And it's leaking 500 gallons per hour. Write an equation that models the amount of water in the pool in terms of hours. So water in the pool is the important part. It's equal to 8,000 minus 500 gallons per hour. So gallons is y, and hours is going to be our x. So let's write that as total gallons is equal to 8,000 minus the 500 per hour. And again, it's kind of flip-flopped. We need to switch those around. That's a negative 500x and a positive 8,000. So when we rewrite that, it's negative 500x plus the 8,000. So when we go to graph that, we're going to start at 8,000 and we're going to go down 500 for every hour. Down 500 over 1 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 hour. It's the same as going down 1,000 every 2 hours. Down 1,000 every 2 hours. It's a nice straight line. Just continue on the line in that same pattern. Constant rate of change. There's our graph. Let's try one more. And remember, these word problems are written specifically for you to use slope-intercept form. A balloon was 10 feet off the ground when it was released. It then rose in the air 15 feet per second. We're going to write an equation that models the height of the balloon in terms of seconds. So our height equals 10 feet plus 15 feet per second. Our height in feet is going to be the important part, the y, in terms of seconds. Seconds is going to be our x. So let's rewrite height it's equal to 10 plus 15 per second. Y equals 10 plus 15x. Remember, that's a positive 10. And we can just flip-flop these to make it y equals mx plus b. Y equals 15x plus 10. Remember, that's a positive 10 to go with our plus 10. Okay, so we're going to start at 10. We need to change our graph a little bit. Instead of 1, let's make these all 10s, 20s, and 30. Now we can write 10. We start at 10, and we're going to go up 15 per second. Up 15, up 10 plus 5 over 1. Up 5 plus 10 over 1. Up 10 plus 5 over 1. Up 5 plus 10 over 1. Nice straight line. No big deal. So remember, sometimes these word problems are going to be written so you can go directly into slope-intercept form. It's going to tell you where you start, and you need to pay attention to how far up and down you're going to go, pay attention to what the rate of change is going to be. And where you start for this one was going to be a 10, so you put a 10 right there on the y-axis, and then just go from there.